Hello and welcome! This video will be about how to achieve high storage speed in Azure, in any cloud, basically with Windows Server operating system by combining multiple disks. So let's see. First, a bit of theory. So if we have, for example, one disk, we will get speed of only one drive, but let's add more. So let's add, for example, 3 drives. And let's say one drive speed is 200 megabytes per second. If we use all 3 drives at once in parallel, then we should get how much? 600 megabytes per second total throughput. I'm not talking about IOPS because you will not saturate IOPS probably in the cloud. So throughput, that is what you will saturate and that is what you will be limited on. Let me tell you about storage spaces and storage pools. Storage pool is a list of disks. So this list of disks, that is a storage pool, list of disks. But that is not visible to the operating system. What is visible to the operating system are virtual disks. That is basically a storage space. Storage spaces. So these virtual disks, for example, L, T drives, these virtual disks are visible to your operating system. And they are built, these virtual disks are built on top of this storage pool, on top of these physical disks. So you specify, everybody loves to specify size, but I'm more interested in performance. And how to achieve good performance? There is a crucial thing called column count. Column count, I cannot stress enough, that is super important for speed. When you create a virtual disk, you specify column count. You create another virtual disk, you specify column count. You create another virtual disk, you specify column count. But what that means? That means how many disks will work at once when you are accessing them with the process. For example, if we define column count 1, that means for this E drive, that means we will use only one disk at a time. It will switch to the second one, to third one, again to the first one, but at the time you will use only one disk, and which means you will get the speed of only one disk, which is currently 200 megabytes per second. If you say, I will use column count 2, that means you will use 2 disks at once. That means you will get the speed of 2 disks. That will change. It will be first and third, second and third, first and second. That will change, but at once you will use maximum 2 drives. That means you will get maximum speed of 400 megabytes per second. If you want the best speed, you need to set column count to 3 because you have 3 drives, and then you will get 600 megabytes per second. So this column count can be minimum of 1 because you cannot use less than 1 disk, and maximum of 3 because we have 3 physical disks. It cannot be bigger than number of physical disks you have. So this is our maximum number of columns and maximum speed we can achieve, which is 600 megabytes per second. But this column count is hidden feature, hidden thing. You don't see it in GUI. Windows will set it for you silently, and when you want to view it, it's hidden below many clicks, hidden deep inside dialogues. So it's really, that's a basic thing, crucial thing, but it is so hidden and so I don't think people are even aware of this, how important this is. This is the setting, more important than size, I would say. This is the crucial setting to set, and it is unchangeable. When you set it to one virtual disk, you cannot change it anymore. And that is the thing which is really, I mean, if you want to change it, you basically need to create another virtual disk with the column count you want and copy all the data over. So you really need to set it right from the start. And that we will do right now. So let's go to a virtual machine. This is Windows 2019, and we will use GUI. First, let's look at the disk. So go to disk management. Let's see what disks we have. So this is let's say a big machine. It has a lot of disks. 1, 2, 3, 4, 5, 6 disks, each of 1 terabyte. These disks of 1 terabyte are so-called P30 disks. Let me show you what I mean. When you go to Azure portal, Azure disks, you search Azure disks, you go to which types of disks are available. And you go to premium, and then you see price per month, if you reserve it for 1 year. And you see here throughput per disk, maximum throughput this disk will give you, megabytes per second. And P30 is 1 terabyte, 200 megabytes per second. So you get with one P30 drive, which costs about $116, $117 per month, you will get 200 megabytes per second. I'm not looking at IOPS because, trust me, you will saturate this one. 200 megabytes per second. And let's look at the machine sizes. So Azure sizes, Azure machine sizes. So click on the first. And then you see virtual machine sizes, memory optimized. Let's see memory optimized, version 4. Click on version 4, that's the newest version. You have first one series, then other series with S. Use this one with S, let's say. And then you see this table. And this table is very confusing because you see number of CPUs. For example, you need 48 CPUs. These are hyper-threaded CPUs. So you get performance of 24 cores because that's just logical, 48 cores, hyper-threaded. You get this amount of RAM, temporary storage size, but look at the disks. Disk information is so crowded that you are not aware of what is the machine limit of this particular machine. Let's say this one. What is the machine limit? Machine limit is 1020 megabytes per second. That is throughput limit of all the disks together. That means this machine, if you combine all the disks together, cannot give you more than 1000 megabytes per second. That's the limit. If you see smaller machines, the limit is 32 megabytes per second. Wow, that's really slow. Or 100 megabytes per second. And you put one disk that is 200 megabytes per second, and it will be cut to the machine limit of 100 megabytes per second. That's really a low machine limit. That means all the disks together, summed up, cannot give you more than 100 megabytes per second. Very, very low limits. And that's not only in Azure, that's also in AWS, Amazon, Google Cloud. That's every cloud provider. They won't give you a big speed throughput through network storage, to their SAN, because they stack multiple machines, virtual machines, and they cannot give you all the bandwidth, and they'll give you only a fraction. Even on big machines with a lot of CPUs, you will only get slow disk throughput. But let's achieve this throughput. We have that throughput available, 1000 megabytes per second. Let's achieve this. How to achieve this? How many disks we have? How many disks we need to achieve this throughput? If we buy P30 drives, we need 6 disks because This is a little bit higher than 1000 megabytes per second. And if we really want to reach this limit, we need to go with 6 times 200 equals 1200 megabytes per second. So we need to go with 6 drives to achieve this limit. That's why our virtual machine has 6 drives. 1, 2, 3, 4, 5, 6 P30 drives. And let's combine these drives together to give us combined speed of 1000 megabytes per second. We could do 1200 if we would not be throttled by machine limit. But okay, let's start. First, you open Server Manager. Then go to File and Storage Services. And you will see these disks here. They are offline, 6 disks. If you go to Storage Pool, which is a list of disks, you will see a primordial storage pool. That means disks which are not in any storage pool will be listed there. And these are these 6 drives. So let's create a new storage pool. We will say SQL pool 1 because it's for SQL Server. It can be for anything. I'm adding a 1 because if you have multiple nodes in the cluster, they will be all visible together in this GUI. And to separate them, don't give them same names. So I will end with 1 for first node, 2 for second node, etc. So SQL pool list of disks 1 is what is the name I will choose. Then I will select all 6 drives, automatic allocation, next, create. So storage pool is created. We have a list of drives created, storage pool created. Let's create a virtual disk on top of this storage pool. So create. This pool, we don't have some other pool of drives. So don't show that again. Next, name of the pool, SQL data, name of the virtual disk, SQL data 1. So this will be used for SQL data. And we want simple layout. That means RAID 0 or striping to get maximum speed. In cloud, you don't need to worry about not having redundancy because storage that it is placed on has redundancy. So you can safely use simple always. Thin provisioning, meaning that actual occupied space will be not what you specify here, but it will be equal to sum of all files you put on that virtual disk. Just the files. So I will specify size in terabytes. It will be, because I have 6 drives of 1 terabyte, that is 6 terabytes in total, but I will give 4 terabytes to data. And notice that there is no option for number of columns. So we depend on internal logic that will determine number of columns here. Create. But on Windows 2019, it is good. It will really create a number of columns equal to number of disks, which is 6. Maybe on older version, it will not, so we need to check. Okay, we created a virtual disk. Now, if you see disk management, all 6 drives disappeared when we included them into a storage pool. But now we have one 4 terabyte drive, which is a virtual disk. So now when create virtual disks, they will be listed here as new drives. And whatever size we specify, it will be here. We can over provision. We can say 10 terabytes. Doesn't matter. But it's not good to over provision, of course. So let's create another one. It will be on this pool, and it will be SQL log 1 for log files. Then we will say simple, thin, and 1 terabyte. Create. close. Then we will create another virtual disk, which is called TempDB1. You know what it is for. Simple, thin, 1 terabyte. Now let's check what is the number of columns. Right-click Properties, then go to Details, then select Number of columns. It is 6. So we are good. It is good. We created virtual disks with 6 columns. That means we will really achieve desired speed. And it is not here in any column. You cannot select that number of columns to see it here. You really need to click all the way, right-click, Properties, Details. Now select number of, where is it? Number of columns, and then you will see it. So it's really, you need to click all the way for each one to verify. It's really clumsy. It's really, not user unfriendly to see the crucial information about the virtual disk. So this virtual disk is what the operating system sees as a drive. And this is the storage pool, which is a list of physical disks. And we currently occupy 0 space because all the virtual drives are thin provisioned, and we are not having any files. They are just maybe some overhead for allocation. So that's why it's not completely 6 terabytes. It's a tiny bit less. We can expand these virtual disks, but we cannot contract them. So keep that in mind. Okay, now we need to create partitions. So we will create new simple volume. Okay, full size, blah blah, add letter, but I won't do that here because I can do it here. Partitions are called volumes here. So you go to volumes, you have a C volume, and now we will create the volumes. Or you can do it here. So I will create on SQL Data 1, I will create a new volume. You right click, new volume. Don't show this again. So this is a partition on this server, but it's local server, of course. I want to create a partition on the local server. On this virtual disk. Next, I want it maximum size 4 terabytes. And I will give it drive letter E. NTFS, allocation unit size 64K. For SQL Server, SQL 64K. And label SQL Data. Next, create. Close. Now we have in our disk management, we do see this partition is created. And if we go to my computer, we will see we have that 4 terabyte disk created, and this drive can achieve really 1200 megabytes per second. Now we can do that for the rest, but I won't do it like this. I will do it with PowerShell. So let's do it with PowerShell, not with GUI, too many clicking. We will open PowerShell, and we need to open it as administrator because we will create virtual disks and stuff. So we need permissions, administrative permissions. Let's see which disks we have that can pull. I mean, I will press F8, which means run selection. That means run only one line where the cursor is. I don't need to select anything. I will just place the text cursor here and press F8. So it will list me disks, physical disks that can pull. I can also view them with disk management, and I will see 6 terabyte, 6 drives, 1, 2, 3, 4, 5, 6, size 1 terabyte. They are all offline. They are not online yet. But that is good for creating a pool. So we will select these disks where device ID equals 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5, 6. These are the disks we will select, F8. Then let's list them. Okay, all 1, 2, 3, 4, 5, 6 disks. Then we will create storage pool. But to create a storage pool, we need so-called storage subsystem. So let's select storage subsystem, F8. And this dialog opens. And this is the list of all storage subsystems. If you would have a cluster, if this would be a cluster, then you would see also this cluster, I believe. So this is not in the cluster. This machine is not part of the cluster. So you see only one Windows storage. You select it and press OK. Now let's view it. Yeah, that's Windows storage. Now create a new storage pool, SQL pool 1. Storage subsystem is what we just selected. Physical disks are what we just selected. And logical size is this, F8. Pool is created. Let's see it. F8, yes, SQL pool 1, 6 terabytes. Allocated size is almost nothing, 1 gigabyte. So let's see what physical disks we have. F8, I pressed F8, but they are, media type is unspecified. If you have media type unspecified, then you will not be able to create virtual disk. And therefore, we need to set media type to SSD. This line will do it. Press F8. Now all physical disks, you see they have media type SSD. Good. Let's go further. We create from the pool, from this pool, we create new virtual disk with SQL data 1. Resiliency is simple, that means striping, and size is 4 terabyte. But provisioning is 10, that means occupy only space of the files. And number of columns is 6. So there you can really specify a number of columns. That's really good. If you have older Windows that take less than number of disks, then you need to use PowerShell and specify explicitly number of columns like this. So I will run all three, F8, and done. So let's see virtual disks. Yeah, all three virtual disks are here, 411 terabyte, and then we need to initialize them. So with GPT. Now they are initialized, all three. Now we need to create partitions. We need to create partitions. Okay, all three partitions are created. Now we need to format this partition with NTFS and allocation unit size 64K. All three are formatted. Now set the labels for E, L, and T. SQL data, SQL log, and TempDB. These are the labels. For example, if you go to ELT, 4 terabytes, 1. No name here. So we will do this to specify labels, to specify names. And once I do that, you see SQL data, nice names, SQL log, TempDB. Now let's check what virtual disks we have, what number of columns. This is very useful. I will copy that query so you can have it. So in this node, SQL 2019, I have these virtual disks, SQL data 1, SQL log, and TempDB. Column count is here. This is super important. So this is column, number of columns that you need to check. You can even run this query, this PowerShell for each. You can run it on your existing system in the cloud just to check what is your number of columns. Does it match number of disks? And that is to achieve high speed of disk. You need a lot of disks combined in a single big pool and specify as much as you can columns. Then you will achieve that machine limit. Thank you very much for your attention. I hope you liked it. Press like button if you do, subscribe, and check your machines and check if you can achieve higher speed than you currently do. Thank you. Bye bye.